To another video. Today we're going to discuss the Wronskian and linear independence. Sorry, let me just set up the camera really quick. Okay, so we're ready. So when we have two functions like let's say y1 and y2, imagine if we could find y2 as a combination of y1. Like y2 was just 3 times y1. It means that like y2 is dependent on y1. So if you're thinking in terms of like linear algebra and you're thinking that hey, like y1 can already like reach this value, so like there's no point. So basically y2 is like dependent on y1, so I don't need it. So if y1 and y2 are linearly independent on an interval if they are not scalar multiples of each other. So remember that as a rule of thumb. And so like think of this in terms of vectors. I guess this is a little abstract, but if you had a couple of vectors, right? Like let's say one, like this is v1 and this is v2. So imagine you could create like a linear combinations of both of these to like span this plane, right? This spans the whole plane. But imagine if v1 was like a scalar multiple of v2. Oh, sorry, my drawing is kind of bad. Imagine if like that was v1, and so like basically you there's no point of that v1, right? Because like that v1 spans everything that v2 already does. Like the function y1 in this case already spans everything that y2 can, because like y2 is a scalar multiple of y1. So imagine, like, I know it's kind of abstract, but imagine these vectors were like functions, right? So if we're thinking of linear independence in terms of functions, this is the thought process behind it. How would you find out if two solutions are linearly independent? So basically, we usually use this in the case of like differential equations. Like you'll get like a general solution. I hope you know what that means. It took a little time for me to understand, but it's not too bad. Imagine you have this. So if you think about it, we have like this function, the y, the general, has like two parts to it. So this would be y1 and this would be y2. Alright, so how do I find out if these two are linearly like dependent on each other, right? So let me just refer to like I'm kidding, I don't look at his video obviously to make this video, but what I would do is I would write y1 and then find the different differentiation of that, then y2, then find, basically the reason why I'm doing this is because if you differentiate y1 and get y1 dash, and if you differentiate y2 and get y2 dash, if y2 is a linear combination of y1, when you differentiate it, it's still going to like be in the form of like y1, right? Like imagine, like if it was, so like that would mean that y1 y2 dash would just and then you take y2 and y1 dash. So in this case, what would it be? So e raised to minus t, the differentiation of that is minus e raised to the minus t. Then t raised to e minus t, you gotta differentiate that, use the product rule. It would be something like e raised to minus t plus t, wait, minus t e raised to the minus t. So obviously that is different compared to like this differentiation, right? So we clearly know that this is not gonna be equal to 0. But like if this was equal to 0, we know that like we know that this and this are like, if it was 0 they would have been linearly independent, because we know that y2 is a scalar multiple of y1, but that is not the case. So yeah, that is all, and I hope this was helpful.